Method of indicator for finding expectations. Often in discrete probability, we need to count and find the expected count. For example, suppose I toss n coins, each with probabilities 1 over n, 2 over n, and so on up to n over n of landing heads. Let x be the number of heads. What is expected value of x? If we apply the definition of expectation, then we need to first compute the probability function of x. Since the probabilities are not equal, we cannot apply the binomial formula. We can still compute the probability function by counting, but it gets complicated. For example, to get 2 heads, I could have first coin land head and the second coin land head, and the rest are tails. Or I could have the first land head, the third land head, and the rest are tails, and so on. In general, I end up with this formula. Probability of x equals to 2 is the sum over all distinct pairs, I and j, between 1 and n, of I over n times j over n times the product over all k that's not equal to I and j, 1 minus k over n. Probability of x equals 3, x equals 4, and so on are equally complicated. And after doing all this, we still need to simplify the sum. The method of indicator is a particular way to find expected counts that bypasses all of these troubles. It has 2 steps. Step 1, write x as a sum of indicators. Step 2, apply linearity of expectation. Since expected value of an indicator of an event is just the probability of that event, this reduces the problem to finding the probability of individual events. So how can we apply the method of indicator here? In this case, x is the sum of I from 1 to n of the indicator that the ith coin lands head. So expected value of x is just the sum, I from 1 to n, of pi, and pi, the probability of the ith coin landing head, is I over n. Now we have sum over I of I over n, simplify, and we get n plus 1 over 2. Here is an exercise. Suppose 10 people just came into an elevator with you at floor 0. Each is selecting a floor between 1 and 18 uniformly at random. You want to go to floor 11. What is the expected number of stops the elevator makes before reaching your floor? Solution. For floor I, let AI be the event that at least one person gets out of this floor. Then x is the sum, I from 1 to 10, of the indicator of the event AI. And now, probability of AI is the probability that at least one person gets out of floor I. This is 1 minus the probability that nobody gets out of floor I. And this is 1 minus 17 divided by 18 to the power of 10. This is because I have 10 people. Each one will not get out of floor I with probability 17 over 18. And so expected value of x is 10 times 1 minus 17 over 18 to the power of 10.